All right, we've got another remainder theorem example. And again, two parts to it. You're going to use synthetic division for the first part right here, right, to get the actual remainder. And then remember, if we get 0 at the end, then we write it as a factor, okay? So we are dividing by 4, so we've got 4 in that lovely little division rectangle. We've got a couple of placeholders that we're going to need. We need a 1, x to the 4th, 0, x to the 3rd, negative 13, x squared, and negative 12x. You don't actually need a constant after that. So you can just divide, right? And so ultimately you're going to have 1 coming straight down, multiply diagonally, we get a 4, add vertically, we get a 4, multiply diagonally, we get a 16, add vertically, we get a 3, multiply diagonally, and we get a 12, and add vertically, we get a 0. So we did get a 0, right? So that means that I'm going to switch over and say x equals 4 is actually a 0. X-intercept, root, whatever you want to call it, same diff. That is a 0, so that means x minus 4 equals 0, right? So this right here is a factor. So we can factor it, and when we factor it, we can write x minus 4 because we know that's a factor. And then remember, we did synthetic division, so this was x to the 4th, right? So that means this is x to the 3rd. So this whole thing is x to the 3rd plus 4x squared plus 3x. So that is actually factored, all right, as far as like we have taken, I don't know why it keeps getting rid of my purple. I don't know, every time I do this it gets rid of my purple. We've taken this and we've factored it into 2 parts, but we're going to go further because, and I have to shrink that down a little bit, sorry. It's like the lights. I should warn you that I'm shrinking it before I shrink it, or warn you that I turn the lights on before I turn the lights on. You can actually even, whoops, yes, I like the purple. Nope, I don't want the purple, I want the blue. These all contain an x, so you can factor an x out as well. So I'm going to factor the x and put it out front, and then I don't know if you can hear the music in the background. I'm listening to Lady Gaga right now, so if you can hear it, I apologize. So x times x minus 4, and then this is going to be x squared plus 4x plus 3, right? Hey guys, 2 numbers that when you multiply them you get 3, and when you add them you get 4, 1 and a 3, right? So x times x minus 4 times x plus 1 times x plus 3. This bad boy right here is completely factored. And we started with one value that we had, did a little bit of synthetic division, factored out a GCF of x, and then it was a simple factor. And now we actually have all 4 zeros. It's a 4th degree polynomial, and we have all 4 zeros. We could graph this if we wanted to, but we don't want to right now, do we? I didn't think so.